Okay, so the ratio and the root test. Okay, so the ratio test says if you're given an infinite series, some arbitrary sum of a sub n. Now, if the limit as n tends towards infinity of the absolute value of a sub n plus 1 divided by a sub n, if this is less than 1, then the sum of a sub n is absolutely convergent. All right. Now, if the limit as n tends towards infinity of the absolute value of a sub n plus 1 divided by a sub n actually equals 1, well, in this case, the test is inconclusive. Right? And now if the limit as n tends towards infinity of the absolute value of a sub n plus 1 divided by a sub n is greater than 1, then the sum of a sub n is divergent. All right, now think about this. This top one is saying it is absolutely convergent, okay? This bottom one is saying that it's divergent. And we have to consider, so we have two extremes at this point, okay? We have absolute convergence and we have divergence. So where do all conditionally convergent series exist? They exist inside of here when the ratio actually equals 1. So you gotta think that's a pretty big statement right there. Saying, yeah, if you do the ratio and it's less than 1, you're absolutely convergent. That's awesome. If it's bigger than 1, you're divergent. So you're done, you're divergent. But if the limit of the ratio actually equals 1, ooh, we don't know. And so that's when you're going to have to, it could be absolutely convergent, could be conditionally convergent, could be divergent. We don't know because the test is inconclusive. But all of the conditionally convergent ones will exist where their ratio equals 1, and all the p-series will also exist on that level. Okay, so let's do an example. Let's start off with something really simple. Let's say we started off with, if I can get this piece of paper. Let's say the sum n equals, let's start at 0, to infinity of 1 divided by, let's say, 2n factorial. Okay? And we were going to investigate the limit as n tends towards infinity of the absolute value of a sub n plus 1 divided by a sub n. Okay? That would equal the limit as n tends towards infinity. All right, so we're going to have 1 divided by now 2 n plus 1 Now factorial divided by 1 divided by 2n factorial. Okay. Well, we can drop the absolute value signs at this point because everything's positive. And so we could say, you know what, that's the same thing as saying 1 over 2n plus 2 factorial, then divided by 1 over 2n factorial. And now I can flip that bottom one upside down. And so that becomes 2n factorial divided by 2n plus 2 factorial. Right. And so that would equal, if the limit as n tends towards infinity. All right, now when we write this out, that's going to be 1 times 2 times 3 times 4, dot, 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 all the way out to 2n minus 1 times 2n. And now divided by 1 times 2 times 3 times 4, dot, 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 and we say 2n minus 1, 2n, 2n plus 1, and 2n plus 2. Okay. And now, after doing cancellation, that's going to equal the limit as n tends towards infinity of 1 divided by 2n plus 1, 2n plus 2, which would equal 0. Okay. So, by the ratio test, the sum n, which equals, I believe I started at 0, to infinity of 1 divided by now 2n factorial is, we'll use an abbreviation, absolutely convergent.